Imaging science. The rapid growth of high-technology industries in areas of electronic printing, medical diagnostics, computer and robotic vision, and satellite photography has created a new demand for scientists with a background in basic sciences and a specialized knowledge of how images are made. Once, imaging science meant photography or films, but today, pictures are created with methods far different than ordinary cameras, and these pictures are called images. Images can be created with sound waves, as in ultrasound. They can be made with computers, as in electronic still photography. They can be sent from space, as in remote sensing. Some uses of remote sensing include studying a drought in Africa, determining the condition of crops in the Soviet Union, or measuring pollution in the Genesee River. Medical diagnostics is another important area of imaging science that is rapidly expanding. Among other things, imaging can help locate cancerous tissue masses. Since a top specialist in some diseases might not practice in the same area as a patient in the hospital, the image can be sent by computer to wherever it is to be interpreted. Electronic printing, including text and the use of halftones and color, is the third main growth area in imaging science. There will be a tremendous increase in the use of desktop publishing in the production of newspapers, magazines, and books. With all these new uses of images, there is a need for scientists who can convert images on a screen to images on a copier, read an image from space and retrieve information from it, sharpen images for high-definition television.
The thing I like about imaging science is that it covers a lot of different sciences and a lot of non-sciences also, such as graphic arts, photography, and satellite remote sensing, medical imaging. There are just so many different things. And the neat thing about it is that there is some common thread among all these things, and finding that common thread is a real interesting as well as very satisfying, that you can see the whole picture of a lot of things.
By the year 2000, nearly 80% of all industries will need imaging scientists, and Rochester Institute of Technology will be the international leader in educating them. RIT is the only university in the United States to offer the entire spectrum of degrees in imaging science, from a bachelor's degree to a PhD. Master's degrees are offered in imaging science and in color science, a program that looks at the psychology and physiology of color. RIT is assuming the international role in imaging science because of its national expertise in fields associated with imaging, including photographic science and the graphic arts. RIT also has developed other new programs in areas with imaging ties, such as telecommunications and microelectronic engineering. Together, these programs are the foundation of the most comprehensive imaging science program in the world.
What I like here most about the Center for Imaging Science and the program is the diversity present in the undergraduate representation from various programs like physics, chemistry, computer science, electrical engineering, mechanical engineering, optical engineering. They all pool in their resources and their individual academic backgrounds to come up with new techniques for imaging.
What I like about imaging science is the student-to-teacher ratio and all the personal attention we receive.
My long-term career goals involve research and development in the field of remote sensing and digital image processing. This is my specific field of study in imaging science. I'm interested in working in atmospheric remote sensing for NASA or for the Jet Propulsion Laboratory, doing image enhancement research in the satellite remote sensing field.
To support the imaging science program, RIT has created the Chester F. Carlson Center for Imaging Science, which is fostering both education and research in imaging science. With 20 laboratories, plus classrooms and an auditorium, the Carlson Center is a resource for the international imaging community. Industry has been a longtime supporter of the imaging science program. Nearly a dozen international corporations have pledged support for the creation of the new building, and more than 20 companies are members of the Industrial Associates, pledging annual support to the program. One of the main attractions is the quality of the students. Imaging science graduates are sought after by industries such as Xerox Corporation, Eastman Kodak Company, and companies worldwide.
In imaging science, we study many imaging systems. These systems are all around us, such as xerography, film, medical imaging. We look at these systems and their components and what their limitations are. And by studying these limitations, hopefully someday we'll be able to improve the systems.
Imaging science was formally established at RIT in 1985 as an outgrowth of the photographic science program. Today, imaging science has about 200 undergraduate and graduate students and visiting scholars from around the world. The faculty bring a variety of skills to the center, including backgrounds in physics, chemistry, mathematics, engineering, optics, and photography. Offering world-class facilities with programs in Graduates for the Future, RIT is leading the imaging revolution.